Okay, so in the first tutorial, did quite a bit of the heavy lifting as it relates to this idea of polar coordinates, translating them to Cartesian coordinates, how we get these XY placement coordinates out of an angle and a radius, right? So there's this stuff. We've kind of glued it together with a little bit of Cartesian coordinates here. So start at the center, let's figure out an angle, let's figure out the radius, so kind of the length of that line that indicates the angle, and then whatever we're using sine and cosine to figure out what the base and the height of that triangle, right? How do we define what that location is? And we didn't even have to get into the whole equation, how this works. We just talked about the back and forth of these functions. So the original quandary, though, was not how to create an animation. It was how to create a shape. So let me go back. Let's say these are 200 by 200 again. All right, so Smarty Pants, I have a shape here. Or sorry, I have an animation, but I have no shape. So how am I going to, what are the next steps with this? So right now we're figuring out angles, at very tiny increments, basically 1 degree at a time, right? The angle 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so it works its way around. We want something where maybe we could make the angle iterate by, 60 degrees each time, so we get this hexagonal shape or something. So before we start up with a variable angle, appropriately named as a variable called angle, and we're incrementing by 1 down here. Really what I want to do is create a shape that happens every single frame. So instead of moving over time, I want to create a bunch of points all at once, well, nearly all at once, like every frame, and then draw that as a shape. So how does that happen? Or how do we go about that happening? So let's go ahead and comment out our angle up here, and let's comment out this one. So we're not going to use that. Oh, and we don't need our print anymore. I think we have a good idea what that's doing. Right, let's just delete. I'm just going to delete all those. Let's make it nice and clean. So I can delete angle. I am going to use angle, but I'm going to use it in a different place, and it's in our friend, the for loop. So for let angle equals 0 as long as the angle is less than 360 degrees, because we want to go around in a full loop. We're going to say angle, plus equals 60. Does that sound good? So we're going to change this 60 degrees. In fact, you know what? A better way to do this, and I think I did this in class, is what if we just say 360 degrees. So that's a full circle, and then we divide that by how many sides do we want this shape to have. So let's say, 3. So we'll do 120 degrees. And we're not going to do a circle anymore. And we'll format that a little bit. So now I have something to drive the angle, so these numbers will change over time, but I don't really have a shape, right? I don't want to put a circle somewhere. What I need are these points that are going to create that shape. And the way processing deals with this, P5, let's go back to the reference. There we go, beginShape. So you can see we call it a function beginShape. That's just a way of telling P5, hey, start. And inside of here, let's put any vertex points that we want. So this would be 30, 20, 85, 20, 85, 75, and then back here. And then we tell it to end the shape and actually close it. And we looked at this, I think, in class as well, where we could just say, you know what, don't even draw it as a shape or just draw it as lines. Fill it in, no fill, but let's just draw the shape without completing it. There's these crazy ones with triangles and triangle strips and triangle fans and all kinds of weird things, right? So we won't worry about that one, doing anything fancy. Let's just deal with beginShape and vertex. So let's go back to our tab here. So at the very beginning, the first thing is that we're going to create a vertex. So vertex is going to be at the x and the y. And that's all we need to do. So we're driving this. In fact, this should work. Right? So we don't see anything. So vertex isn't a shape. It's just a point in space. If I wanted to, I could say point x and y as well. It doesn't have to use vertex. And they're going to be very, very faint on here. Let's do this. Stroke, weight, 5. Right, so here we have our triangle set up. So 1, 2, and 3. Based on where you start with the ankle, I'm pretty sure with processing it starts to this right-hand side. This is 0 degrees, 120, 240, and 360, which also happens to be 0. Right, so you can see where these points are, but it's not a shape. So let's go ahead and say, in fact, I'm going to make this bigger. So it's, those points are really obvious. And then what we need to do is say begin shape, right? So this is telling processing, hey, I really want to draw one of these. And outside of the for loop, I'm going to do end shape. Oops, and then close. And close is all caps. Usually when you have one of these keyword commands inside of here, it would be all capital letters. Let's see what we get. Right, so I have my triangle. In fact, maybe what I should do is, well, I'll just leave it like that so you can see this nice, thick, bold line that's there. This will be a little more complicated. The points are still there. I guess what I wanted to mention is, in fact, let's do it this way. Circle, this will be better. X and Y, and let's say 25. Right, so you can see the circles are being drawn here at those locations, right, those coordinates, and then it draws the triangle. So when we say begin shape doesn't care about any of this other stuff. Begin shape only cares about vertice points. So you could put begin shape anywhere to start this process, and any vertex points that get counted in here, you do want to move kind of in a sequence in the direction that it's going to be drawn. If you had a more complicated shape, in fact, let's do that. Let's say 8. Right? So you can see the shape being drawn here, and we have our individual points along the edges. It doesn't care, begin shape doesn't care about circle. It only cares about a vertex. So it says, okay, I've got one of those, got another. We can put vertex positions anywhere. Let's just say vertex. We could even say mouse X. This is really dumb, by the way, but just to make a point. Right, so this is that first point that's being drawn. And I can kind of put it any place, but you can, from this, you get a sense of what the first point is. That's this one that I'm wiggling with my mouse, and then it moves on to the second, and then the third, and then the fourth, and then the fifth, sixth, seventh, eighth. So it's working its way around clockwise to put that point there. Right, so I have a really rough Pac-Man for anyone that's into vintage video games. So you can see let's just stop that for a second and get that out of there. But the vertex can happen outside of the for loop. We're using the for loop just to generate a number of points, and we're spinning those points around in a polar fashion, but converting them to Cartesian coordinates and then feeding them into that vertex, right? So we don't have to necessarily use a for loop. We could just, as the example, put vertex points anywhere. Where are we at? Almost 10 minutes. As I said, all the heavy lifting was done by understanding what this crazy cosine and sine with the angle being fed in here and multiplied by a radius, what that structure is. And again, we have this at the center, but I should certainly, again, to make the point that this would work this way. Right, here's my shape, and it's moving along with that mouse. So if you were using the, I think you're going to use this for the grid example, you could certainly feed this shape into your grid design and use that inside of there. Okay, I don't think I need to recap, and I didn't even have to use the gray board. I think it was pretty self-explanatory where this was going now that we know how the polar coordinates work within this. So great way to deal with directions, animations, but in this example, a great way to draw interesting shapes. And this is the many, many possibilities from this. All right, see you in the next tutorial.